Hello everybody and welcome back. Today we'll be talking about momentum and how to solve problems using algebra. So the main idea with momentum is this idea of momentum equals mass times velocity. And throughout collisions, momentum is always conserved as long as there are no external forces to the system. So for example, in this case, we just have a ball that's colliding with a box. And so there are no external forces on the system, so the momentum is conserved throughout this. Now let's give a few things to this problem to help it make sense. So we're going to say that the mass of the ball is equal to 1 kilogram. And we're going to say the mass of the box, which is also a bad thing, let's do square. Mass of the square equals 5 kilograms. And we can also say that this ball starts off with a velocity of 10 meters per second. And so these two objects collide. And after they collide, the box has a velocity final of 3 meters per second. And so what we're trying to find is what is the final velocity of this ball after the collision? And so also we can say that this box starts with an initial velocity of 0 meters per second. So what we can do is what's called the conservation of momentum equation. So we can say that the momentum at the beginning is going to equal the momentum at the end, and we can break this even further by saying that the momentum initial of the ball plus the momentum initial of the square equals the momentum of the ball final plus the momentum final of the square. And so we can use this formula up here to write it even further and say that the mass 1 times velocity 1 initial plus mass 2 times velocity 2 initial equals mass 1 velocity 1 final plus mass 2 velocity 2 final. And so in this case, mass 1 is the ball and mass 2 is of the square or the box. But what we can notice is that if this box starts out a velocity of 0, then we can say that the initial velocity of the second one equals 0. So that kind of simplifies our equation, and what we can do is plug stuff in. So we can say that the initial mass is 1 kilogram times the initial velocity, which is 10 meters per second, and that equals 1 kilogram times what we're trying to find, plus 5 kilograms times 3 meters per second. And so what we can do is we can rearrange this, and what we can do is, okay, so this is equal to 10, this is equal to 15, so it's addition, so we can subtract 15 on both sides to get that negative 5. So we can rewrite this up here. Negative 5 equals 1 kilogram times the velocity 1 final. And I guess we should also say that this is in terms of kilograms times meters per second, so that then we divide by kilograms on both sides. What we get is that negative 5 meters per second equals this velocity final. And so there are ways to check, like for example, we could plug this back in, but I think one of the easiest ways to check would be to actually test it. Unfortunately, I don't have a ball in a box that I can use to collide and collect accurate data on, so what we're going to use is a physics simulator to see if these values are correct.